Hey guys, welcome back. Today we're doing a lesson on what is called functions and formulas. So mostly I'm going to talk about how do we deal with formulas and how do we solve different functions and use them in real life scenarios. So our key concepts today is that there are like lots of formulas in math, science, and business that can be represented mathematically by polynomial functions or other functions such as exponential functions. And we've seen exponential functions already when we did our exponential function unit. And we've seen some math ones when we've done our geometry. So we've already kind of done some of this stuff already. So hopefully it's just kind of a review lesson today. But formulas can be solved for an unknown just by substituting what we do know directly into the formula and solving for the unknown. However, today we're going to focus kind of on this last part. You may need to rewrite the formula or rearrange it in order to solve for the unknown. So I'm going to talk about how do you do that, because I know there's a lot of people who are like, great, just give me the formula, I'll substitute the numbers in and we're good to go. But there's a lot of the times that the formula is not the way you want it. And I do have students who get upset and are like, I don't know what to do with it if it's not solving for exactly what I want to solve for. But you guys have the tools to do that. I'm going to show you how we do that with an example, and you'll get lots of practice and the practice questions and whatnot. So moving down the page, I have a couple examples here for us. So this one, we're going to rearrange a formula. So what we're going to do is we're going to convert 30 degrees Celsius to degrees Fahrenheit. And here's the formula. Now notice that the formula they've given us is Celsius. But what we really want to do is make it so it's F equals something. So that involves us rearranging the formula. Rearranging the formula just means that we're going to move things over to the other side of the equation so that we get F all by itself. That's really the goal. We want F to be alone. And the way you do that is whatever operation it is on one side, we're going to do the opposite on the other side. I'm going to show you how that works. So first things first, we've got C equals 5 F minus 32 divided by 9. Now, I always deal with the multiplication and division first if I can. And the first thing I want to do is move that 9. Now, when I move the 9, we're going to move this first. It is dividing on this side. When you move it over to the other side, it does the opposite. So if it's dividing on the one side, it's going to multiply on the other side. So let's do that first. It's going to be 9 times C equals 5 F minus 32. Beautiful. So the 9's not there anymore. The next thing we're going to do is I'm going to move this 5. And you'll notice it's multiplication on this side. So when I move it over to the other side, it's going to be division. So it becomes 9 times C divided by 5. And we're left with F minus 32. Last thing, because F is still not by itself and we want it by itself, we're going to move. Sorry, guys. We're going to move that 32 over. So because we're going to move it over, it's minus on this side. It's going to become plus on the other side. So what happens is we're going to keep this all together, but it's going to become plus 32 equals F. And now this is the formula we're going to use to change our degrees Celsius into Fahrenheit. So the last thing you're going to do, substitute that 30 degrees in and we'll solve for it. It's what like one of my professors used to call plug and chug. Once you have it, plug the numbers in that you know and then just calculate. So 9 times our degrees Celsius, which is 30, divided by 5 plus 32 is going to equal F. And then all you have to do is actually calculate it. So on my calculator, 9 times 30 divided by 5 plus 32, and I get 86 degrees Fahrenheit. Perfect. So you always do the opposite when you're moving things over. Let's try a different example. I'm going to move the sheet down and we'll try the last example. All right, so the area A of a circle with radius r is A equals pi r squared. We're going to use the formula to determine the radius of a circular oil spill that covers an area of 5 kilometers squared. So we're not finding the area in this one. We're going to find the radius. So the idea right now is we can do this two ways. So method 1 is to rearrange and solve. Rearrange and solve. And method 2, I want to show you both ways, is to substitute and solve. Okay, so the first one requires us to move the equation around. So when we move it around, we want to get r all by itself, pi r squared. So the first thing I'm going to do is get rid of that pi, not get rid of it, but I'm going to move the pi over. It's multiplication on this side, so it'll be division on the other side. So a divided by pi equals r squared. Now, yes, we have r all by itself, but we want to find the radius. We don't want to find the radius squared. So in order to change that exponent, you're going to take the square root of each side. So if you take the square root of a over pi and the square root of r squared, the squared is going to disappear because they cancel each other out. So you have the square root of a divided by pi equals r. Super simple now. We're just going to plug in 5 kilometers squared for a and solve for r. So 5 divided by pi, I'm going to square root it, is equal to r. And when I calculate it, 5 divided by pi, and then I take the square root of it, I get that r equals 1.26. So that's the one way. You're going to rearrange it first and then solve it at the end. The second method, some people like to use this one instead, is we're going to substitute and then we're going to solve. So this requires, we're just going to use the formula as it is, pi r squared, and then we're going to substitute the 5 in, pi r squared. I still want to get that r by itself, so 5 divided by pi, and I will calculate that. 5 divided by pi, 1.591549 equals r squared, and then I'll take the square root of it. Which gives me 1.26. So you still get the same answer. It's just done a little bit differently. So in the method 1, we rearranged it and then did our substituting and solving. And in method 2, we substituted everything that we could and then we solved it. And we kind of did the rearranging as we went. It's up to you how you want to do it, whichever method works best for you. Just be aware, some of the questions will ask you to do method 1 first. Some of the questions will ask you to do method 2, or it will just leave it up to you and you choose the method that you want to do. But really, unless I specify it on a quiz or something, and if I specify it on a quiz, you'll have to actually show me how to do it. But otherwise, it's up to you. Use the method that you are most comfortable with. All right, and I'll see you guys later.